let's look at our lines here. And again, we have nice straight lines developed from our siding. And you can see a disruption in here. The building's obviously leaning to one side. Okay. The windows are, and the framing of the window is also disrupted here. Okay. You can see the lines are no longer straight. This house, if you were to look down the side, if you were standing at this corner and looking this way, there would be a wave to the house. All right? Okay. Let's take a close look at this. All right. What do you guys see? The porch is collapsed. But the house looks okay. Tell me, we have nice windows here. Our lines are straight. Okay. Our windows in here are okay. The porch is collapsed. All right. You need to be very careful when you look at porches. In some of the older houses, the porch is an integral part of the house. Okay. So you have to look very closely where the porch is connected to the house. And if I were inspecting this house, I'd look underneath here and take a really good look. A lot of porches are just connected to the house, or separate. All right. So this would be considered a hazard area. We want to stay out from underneath, which means that we're going to have to look for an alternate way in. We're not going to go to the front door. All right, we're going to go to the back door in this case. One of the things that we generally do is when we look at epicenters, and the epicenter is the point where the actual focus of the earthquake may have started underground. The epicenter is the point at the surface where the waves irradiate outward. Just because you're right on the epicenter doesn't mean that you're going to have the most amount of damage. It depends on the geological layout. In the Bay Area, what we have is we can get amplification of the shock wave because of the base soil and the ground, or the base rock. So in the Bay Area, especially around San Francisco Bay, we get amplification of shock waves. So even though it's a 7.4 earthquake, it may be actually a little bit larger feeling depending on the geology of the area you're in. Okay? So strict distance is not absolute criteria for amount of damage, okay, from the epicenter. Okay. Now what's this? This is a complete collapse, right? This was a 3-story building that's now a 1-story building. All right. This is light, medium, or heavy?
Heavy.
Heavy. Would you go into it?
No.
All right. Okay. But that is a wood frame house. Okay. Now, we do want you to recognize a few things about this. Okay. You need to know, because you're going to be the first ones there, how this building fell. And there's several collapse patterns. You also need to know not only the pattern of collapse, but also the size of the voids, or the spaces in the building. The bigger the space, the more survivable area you have in there. What we want is, we want this information because that's initially how survivable it is. We're going to have aftershocks. It's going to change the configuration of that building. We need to know what it looked like when we first started. How do buildings fall? What are those collapse styles? If we have 2 walls and a floor above, and this floor pulls away from one wall and falls straight down, we have what we call lean-to. This is leaning against the wall. And we have 2 void spaces, one great big one here and one here. Okay? If we have 2 walls again and a floor across the top, and it breaks right in the center, we have a V. And we have 3 void spaces to look. Okay? If we have 3 floors, they pull away from both walls almost simultaneously, they fall straight down, we have what we call a pancake. Okay? The void spaces are very small in this. This is the worst type of collapse. And what do we have here? My name in Japanese. Okay. Now, This particular building pancaked, okay? It came straight down and then fell over to one side. All right. So, with that heavy collapse situation, the heavy damage, you guys cordon off the area. You don't let anybody go in. You look at the pattern of collapse and the size of the voids, and then you come and get us. What do? Why do they pay us the big bucks? This is why we get paid the big bucks. We're going to reinforce that building, okay, before we enter. We're also going to do limited searches in areas that we feel are relatively stable. And then we have a whole set of standards which we follow to search that building. But we mitigate our hazards before we go in. Well, that's the same thing you guys are doing. You're mitigating your hazards as you go in. You're going to take care of the electrical and gas, right? Look for your hazards before you go in, all right? Okay, let's look at unreinforced masonry. First, we have to identify it. Deep-setted windows, okay. Bricks, that's pretty obvious. Arch windows and doors, metal plates, header rows, mortar. Okay, bricks. Now, these are the metal plates. Okay. This tie floors together. This has a nice arched window, nice and deep set. These look fairly obvious. Is this a brick building?
That's a brick building?
Is it?
No.
Could be a wood building.
It could be a wood building. It could, if we take a closer look, what we find is that sometimes we cover over the bricks with plaster. Okay? Now, let's stop that. Let's take another look again. There are other signs besides the bricks. What are they? The deep set windows. The gingerbread is... See these metal plates here? And we have metal plates here and here.
Oh, that shows that it's...
Those are the telltale signs. Yeah. So nice deep set window. You might see the arches. Now the other things that you might look for is this. See these patterning here is nice and straight. Those are the bricks, right? Okay. So even though it's covered over with plaster, there are telltale signs. Okay. Question?
Are those metal plates the result of attempts to reinforce, or are they, or repair?
Both. They are reinforcement in some cases, or just the way the building was built in the first place. Okay. What they do is they tie these. You have a wall, two walls on either side, and you have to bolt onto a floor in between there. Okay. And then when they reinforce the building, they'll put more bolting through, and then on the inside they'll do a number of different things. They'll put X-bracings. There's a number of ways of reinforcing the building. Okay. All right. And we do have brick buildings. Again, nice arches. Okay. Familiar buildings? Yes, we have a high density of unreinforced masonry that's being retrofitted. Okay. Again, nice arches. All right. Not all houses are single-family residence, right? We have some duplexes, some triplexes. All right. We have some apartments that shouldn't be there sometimes in Berkeley. Yes.
You can tell by this?
You can. What you have to be aware of is just because it comes in one spot doesn't mean it doesn't come in two spots. All right? So you need to be aware of that fact. Gas will generally come in once. Electricity might come in a couple different times. All right? So you need to be looking for the components there. Let's look at this house again. The garage door is shut, which means it's nice and stable in there. Where is the cripple wall?
What's the cripple wall? That's
The short wall between the foundation
and the floor?
and the first floor.
Level with the front door?
Level with
That would be fairly high, huh?
Yes.
Fairly high.
That's a fairly high, short wall. Now, you can actually see the foundation, right?
Below. Yeah.
Below. And we come up to where
The wood begins.
wood begins, or where we would step into the house. So that's a good 2 feet. So if this house came off its foundation,